Feel free to mingle, talk to each other, and at least some of the time, observe the Zurich Minds rule. And that is, don't talk to anybody you already know.
We are Till and Herbert. We are founders of Kooaba. And today we want to share our passion to make smart visuals. But before we start to explain what smart visuals are actually and what you can do with smart visuals, we would like to present you two stunning numbers. The first number is 900 million. 900 million smartphones with a camera are available around the world with internet connection. And this makes that taking images, digital images, photos, is so much easier than it was before. We can take in any situation, we can take pictures. And so people do, and upload their pictures on the internet, on platforms such as Facebook and Flickr. And the second number is related to Facebook. It's 50 million. 50 million photos are uploaded and shared to Facebook every single day. This means 600 images per second. And this again corresponds to about 20 Hollywood movies playing and every single frame of it uploaded to the internet. We wanted to make it visual to you. It would look like something like this. So that's at this rate images are uploaded on the internet. Actually, the sad thing about it is that this data is completely useless, except you can look at the nice pictures. But why they are useless and what we can do and how can we make them useful with smart visuals, we will explain in the following presentation. First, we're going to explain you how computers and humans see digital images. Then Till will explain you how we make smart visuals. And then we're going to see at some examples of smart images, how we can use them today already, and how we will use them maybe in the future. So, how do computers see images? Let's start with this as an example. Digital images mean a lot to us. It's a lot of emotions. Here, for example, a great evening in Paris in front of the Arc de Triomphe, and passing a great evening and everything. To us, it means a lot with friends and so on. We have all the souvenirs of this one moment captured in a digital image. Computers, however, see things like this, just pixels, raw pixels. Actually, just numbers. A huge stream of just numbers. But back to the original image, what we actually want the computer to see is this. The computer can recognize Arc de Triomphe. This opens a lot of possibilities to do with the image then. We can find it again, etc., etc. Before we will explain how smart visuals are created, how we make smart visuals. But before, let me introduce a second example. This is the case when you are with your mobile phone somewhere on the go, you read a great article, you would like to remember it. What do? You take a picture of the article. And we make a smart visual out of it.
Yeah, by now you're hopefully curious enough to understand how to learn how we convert a regular digital image into a smart visual. The basic process is very simple. On the left-hand side, you have a query image, the image you want to turn into a smart visual. And on the other hand, you have a huge reference database containing millions and millions of images. And in between, you put an object recognition algorithm. What this algorithm does, it takes the query image and compares it to each image in the reference database. And every now and then, we have a match. We recognize, oh, there's the same object present in the image. And once we have found a certain number of matches, we are pretty sure that this object is really present in the query image. And we can transfer the information to the query image and turn it into a smart visual. Around 2000, there was a breakthrough in research, a novel kind of approach done by several labs, but among others by our professor Luc van Gogh at ETH Zurich. And what this approach is, instead of calculating one signature, the algorithms first identify so-called interest points in the image. That's many locations that have very special characteristics. And around each interest point, we look at the patch, kind of a mini image. So instead of representing the image with one large signature, you actually have hundreds of small image patches. So what you do now, if you want to compare two images and find out if they're similar or not, or if they actually contain the same object or not, you take all possible pairings of these interest points and see if they have some similarity by some computational measure. And if they do, you say, OK, that's a match. And if you have a large number of matches, you say, OK, we have really the same object present in the image. Now, the important thing to take away from this approach compared to the old approaches is that from the locality, that means from all these small patches, instead of one big signature, you get robustness. And robustness to scale changes. You see in the left image, the object is a lot smaller. To rotation, it's slightly rotated. Illumination, it's at night. On the right-hand side, it's at day. All these kind of robustness you need. The last thing, which is often very astonishing to people, the whole process doesn't involve any color. So the second take-home message, these days in computer vision for object recognition, color is not important. Maybe it will be one day again, but these days it's not. So even though this has changed a lot, there is still a lot that cannot be done. So the point of this slide, which is actually inspired by our friends at Google, is to explain you a bit what's possible today and what's not possible with image recognition. This is illustrated in this figure. In the center, you have the green area. That's in general what's possible. And the red area is what's not possible. So let's start at the top right. Printed stuff like billboards, magazine covers, CD covers, and so on and so forth works really well, no problem. Works. Gets already a bit more tricky with logos. Starbucks logo, very characteristic. We say it has a lot of texture, very small patterns, very good. Nike logo, the Nike swoosh, very hard to recognize. And it continues with things that people often ask us is, for instance, products, right? Products, well, it depends, right? Wine labels works very well, but camera, a chair, or actually cars at the bottom, very hard to recognize because they have no texture, and even worse, they often have reflection on their surface, which makes it really hard to recognize the object. We go further around the circle, places, I showed you before, works pretty well. Faces, interesting topic, right? Everybody always asks about faces. I mentioned as much, it's a different technology than what we use, but here the case is that you can recognize frontal faces very well, very reliably. Sideway view, very hard, pretty much unsolved. And if people wear sunglasses and so on, obviously it's a lot harder. Further it goes, animals, plants, pretty much unsolved. And text, people always think text recognition, or OCR, it's called optical character recognition, is solved. It's not. It's actually solved for printed documents, shown in the green area, but for text in natural scenes, which has very weird shapes and forms and transformation, not solved. So hopefully you have a good overview, what works, what not. If you would like to summarize that in a very simple concept, it's that humans are really good at generalizing, right? If you look at the left-hand side, you see a cat, even though it's very, very different, right? And this problem of recognizing a cat is called object class recognition, and it's basically unsolved. On the other hand, on the right-hand side, you as a human, if I would just show you these pictures, it would be very hard for you to tell what is the name of that object, but the computer is extremely good at doing that, sifting through millions and millions of images to solve that problem. So to come back to my original slide, how this works, there's object recognition, there's the database, and as I mentioned, the database has to be really large so it works well, right? So you need some additional trickery, which I just want to mention very shortly. First thing is where you get all the reference images from. Basic idea, you crawl them from the internet, but as shown, there's lots and lots of pictures, like baby pictures, cats and dogs, mixed with stuff we can recognize and stuff we can't recognize. So you need some crawling algorithm which separates things into stuff we can recognize and stuff which is junk for us, for our algorithm at least. And it's one of the things we added to that basic object recognition algorithm. And then once the database is really large, this object recognition algorithm is a bit slow. Actually, for millions of images, you would wait days and weeks, right? So you need kind of a turbo, which scaled search makes it 100 times faster. So that's the basic machinery that makes it possible to turn a query image from the left into a smart visual, an image with context. And now it's back to Herbert. He will tell you what you can do with that today and tomorrow.
So now you might ask, what's that for? What can we use that? And actually, you can use it for a lot of things. And that's, at the same time, the problem. It's really exciting, but it's the problem. So, but we show you two examples. You can use it on the one side for when you're on the go, when you're with your mobile camera. And the other example, when the image has already been taken and like in a post-processing process at home in front of your desktop. We call these two applications that we will show you today Paperboy and Shooting Star. Both are available now for free.
Shooting Star allows for effortless photo management thanks to automatic tagging. You can tag images from your PC, Flickr, or the web. For example, I simply upload a photo of the Golden Gate Bridge and Shooting Star automatically tags it using image recognition technology.
Photo management tool. It's web-based and it can automatically tag your image. So it just, when you come back from the vacation, you have thousands of digital images, just upload them to your computer and we can recognize what object it is, in this case the Golden Gate Bridge in San Francisco. We provide additional links such as Wikipedia pages. We tag the object with all available tags and we even recognize where the picture has been taken without GPS information available. And you can see who of your friends has also taken, was also there and has taken the same picture, or a picture of the same object. So besides that, what we're working on, there are thousands of possibilities that you can do. One is interactive catalogs. You can take a picture and order the product. Then interactive museum guides. You're in a museum, want to know what painting that is. In this case, Mona Lisa. Just take a picture and you get all the information about that. And a very exciting application is the wine label recognition to know more about your favorite wines. So, smart visuals for tomorrow. Now we can imagine, I think it starts already in your heads, oh, we could use it for this and this and this. And this is actually true. And one example, there's, again, lots of examples we can use smart visuals. One I would like to share with you is a famous TED talk of Pranav Mistry. I don't know whether that's right pronounced. Please watch it, look it up on the internet. It's really exciting. And he is going with this kind of, like this badge here, but there's a camera, there's a computer, and a projector. And I will show you what he's going to see with that.
The camera is not only understanding your hand movements, but interestingly is also able to understand what objects you are holding in your hand. What we are doing here is actually, for example, in this case, the book cover is matched with so many thousands of, or maybe millions of books online and checking out which book it is. Once it has that information, it finds out more reviews about that, or maybe New York Times had a sound overview on that, so you can actually hear on a physical book as a review of a sound.
Gave a famous talk at Harvard University.
This was Obama's last visit last week to MIT.
And in particular, I want to thank two outstanding MIT
So I was seeing the live of his talk outside in just a newspaper. Your newspaper will show you live of your weather information rather than having updated like you have to check your computer in order to do that, right? when I'm going back, I can just use my boarding pass and to check, oh, my flight has been how much delayed. Because at that particular time, I'm not feeling of opening my iPhone and checking out a particular icon. And I think this technology will not only change the way, yes, it will change the way we interact with people also, not only the physical world.